Hello, this is Miss Moore, and today we're going to talk about intermolecular forces, intermolecular forces. So, today's essential question, what is an intermolecular force, and how is it different from an intramolecular force? Okay, let's start with a review of intramolecular forces. So, an intramolecular force is a force between atoms or ions. Okay. Intramolecular forces are bonds. So ionic bonds, covalent bonds, and metallic bonds. So let's go back to point one real quick. An intramolecular force is the force between atoms. So for example, if I had a C bonded with 4 H's, so C, H4, these bonds right here, in this case, these are covalent bonds. Those pink things are the bonds, also known as intramolecular force. Okay, so again, an intramolecular force is between atoms, between atoms. It's the bonds. And bonds are formed to make atoms more stable or to achieve noble gas configuration. So the really important part about this first slide is that intramolecular forces are between atoms. So the basic bonds, ionic, covalent, and metallic. Let's contrast intramolecular forces with intermolecular forces. So an intermolecular force, they're also known as IMFs, intermolecular force, and it's a force between molecules. And a molecule is a group of atoms joined together by a bond. So let me draw again my CH4. So if we have CH4 written as CH4, let's see. So the white stuff, the C's, the H's, the C's and H's are the atoms. The red are the bonds, or the intramolecular force. And this whole thing together, this whole thing, or that either way, that's a molecule. Okay, so there's some terminology for you. And an intermolecular force, I'm going to get rid of the orange for a second, would be if we had another one of these with our bonds. And let's say, how about green? An intermolecular force would be a force between the molecules. So there would be some sort of, I'm making it dotted line to show it's like a super weak bond, and it's just between molecules. And this would be the intermolecular force. It's not between atoms, it's between molecules, with a molecule being atoms already joined together. Let's start our discussion on the strengths of IMFs here. So, the strength of an IMF, or of an intermolecular force, how strong that force is, just like when we talked about intramolecular forces, ionic, covalent, metallic, those bonds had different strengths. It turns out intermolecular forces, you can think of it as connections between molecules, also have different strengths. And one way to figure out the strength of an IMF is by looking at the properties of a substance, just like we did with bonds, like melting point, boiling point, things like that. And we're going to deal with this in a later lecture. What we're going to focus on the rest of today is that different types of bonds have different IMFs, which means different strengths of IMFs. And that is what we're going to focus on the rest of today. So, here we go. IMFs and bond types. So, substances made up of molecules with covalent bonds have intermolecular forces, or IMFs. Now, I want to be clear. The truth is, single atoms, ionic compounds, and metallic compounds also have intramolecular forces. However, those are the general weaker IMFs, so we are going to focus for our class on looking at the IMFs in covalent compounds, or compounds made up of atoms covalently bonded. Okay, so let's start with nonpolar bonds. So molecules made up of atoms that have nonpolar covalent bonds have the weaker IMFs. So remember that for us, for now, nonpolar bonds are made up of atoms that are touching each other on the periodic table. Okay. So an example of a nonpolar molecule would be something like, let's see, how about, well, we'll stick with our CH4. Okay, so CH4 is a molecule made up of nonpolar bonds, so it's going to have a weak intermolecular forces, versus molecules that contain atoms with a polar covalent bonds have much stronger IMFs. And remember, for us, for now, polar bonds are made up of atoms that are not touching each other on the periodic table. All right, so an example of a molecule that contains polar bonds would be something like NF3. Okay, so the IMFs in NF3 are going to be much stronger than the IMFs found in CH4, because CH4 is made up of nonpolar bonds and NF3 is made up of polar bonds. And let's move onward. The more polar the bond, and what that means, and this is important, it means the further apart the atoms are on the periodic table, the stronger the IMFs. So if we take, for example, we'll use the NF again. NF3 versus OF2. So these are more polar. This is less polar. Because N and F are farther apart on the periodic table than are O and F. So that means that NF3 has stronger IMFs. Okay. And if it has stronger IMFs, that means that the polar molecules will be held together more strongly than nonpolar molecules because of stronger IMFs. Okay, and larger nonpolar molecules will have stronger IMFs than smaller nonpolar molecules. So example of that, all right, so if I had C4H, I don't know, 8 versus C2H4, he is larger, so stronger IMFs, while this guy is smaller, so weaker IMFs. Okay, that could work. Well, let's try this. Let's try one more. So let's say I had, let's see, how about I2 versus F2. So in this case, I2 and F2 both have the same number of atoms, but I2 is a bigger molecule because I is bigger. It has a mass of 126.9, whereas F has a mass of 19. So this guy is bigger, so he also will have stronger IMFs. Okay, and when we look at polar molecules versus nonpolar molecules, the same holds true. A larger polar molecule will have a stronger IMF than a smaller polar molecule. All right. Yeah, I guess that's it for today. Have a good one.